Alright, let's get started. If I didn't already say it, good afternoon, everybody. Okay. So this problem we did for the warm-up is going to lead us directly right into the lesson. You do not have to write this down. It's too much. Anytime I give you guys an extended word problem like this, we're going to write down the key information, but we don't have to copy down the whole problem, especially since this is in your book. The function y equals negative 3x plus 12 gives the amount y in fluid ounces of juice remaining in a bottle after you take x gulps. We're going to do two things. We're going to identify the domain and range, and then we're going to find the range when the domain is 0, 1, 2, 3. Yeah. But we've already done the second part of this problem. We found the ranges, so that's done. Now we're going to talk about identifying the independent and dependent variables. Okay, what is the independent variable in this scenario, and what does it mean in the context of the problem? We'll start with, don't say it, Jonah.
Yes. The domain is 0, 1, 2, 3.
Okay, and what does it mean in the context of this problem?
That's actually the infinite variable because it's the goal
Gulps you take. We're going to say the independent variable represents the gulps we take. Or we'll say the number of gulps. And you identified the actual domain as 0, 1, 2, and 3. Very good. Okay. What is the domain? Yes. I forget. Gabrielle. Go ahead, Gabrielle.
0, 1, 2.
No. I'm sorry, the dependent variables. We'll just say juice remaining in the bottle. Well, we should say ounces. Ounces of juice remaining. And what are the amounts?
12, 9, 6, 3, 9, 3, 6, 9, 12.
Good. Okay. So we've identified what the dependent variable is, and we've identified the actual numbers. The same thing for the independent variable. And we used the domain that was given to find the corresponding range. Now this, y equals negative 3x plus 12, is actually a linear function, and the domain and range of any linear function, well, not always, but most of the time, is infinite. There's infinite numbers in both domain and range. However, they are limiting the domain to these four numbers, so therefore, what type of domain and range are we talking about for this problem? We learned about this vocabulary term yesterday. Starts with a D. Discrete, right. So even though this is technically a continuous domain and range, they're limiting it to only those 4 points. So we're thinking of it in terms of being a discrete function. Okay. Any questions about this? We're going to do the same thing again. With a different function. So here we have y equals 24x. end, it says the function y equals 24x gives the number of y bottles of water you have after buying x cases. You can identify the domain and range, and we are going to then find the range if the domain is 0, 1, 2, 3, and 4. So it's pretty much the exact same problem. So before we start this, I'm going to ask you this question. I'm going to discuss this question. If I did not tell you that y was the bottles of water and x was the cases, how would we know which one is the dependent and which one is the independent? So when you don't have that information, this is the question you want to ask yourself and think about. Which one depends on the other one? Do the cases depend on the number of bottles of water? Or do the number of bottled water depend on the number of cases? It's easier on the last one when we talk about the juice and the gulps. Does the number of gulps depend on the juice, or does the juice depend on the number of gulps? The juice depends on how many gulps you take, right? How much juice is left in the bottle depends on how many gulps you took. So the juice was the dependent variable. Here, the number of bottles depends on the number of cases, right?
Yes.
So that's our dependent variable. So if they don't tell you which one is x and y, you can figure it out by working through the problem and thinking about which one is dependent on the other one. Okay, so what is my independent variable?
Number of
The number of cases.
Cases. And what is my my dependent variable?
the number of bottles after buying
So my number of bottles depends on my number of cases. And we have our domain, 0, 1, 2, and 3. And we're looking for our range, which is, I'm going to let you guys figure that out. I'll give you 1 minute. Plug these numbers into this equation and tell me what we get as our outcome. I know some of you have already done it. Just give everyone 1 minute. Yes. Okay. Which part? All of it? Okay, so basically what we're doing is we're given these 4 numbers for x. We're supposed to find these 4 numbers for y. We do that by plugging them into the equation that was given. Okay, do you understand that? Do you know how to plug them in? So our current equation is this. So one at a time, take this number and plug it in for x. So we do 24 times 0, and then we'll do 24 times 1, and we'll do times 2 times 3. We're going to get 4 numbers. Is that where you were hung up? What? You don't have to ask. Okay. I still have. If anyone says anything, say, Mr. Mylan's a terrible teacher, you just let me go without a pass. I'll blame it on Gabrielle. Okay, yeah, he's got my back. You got my back?
See the X now.
Sure. One at a time. Not all at the same time. So when you plug it in, basically you're multiplying it. So even though there's no symbol here, this means 24 times x. So if we replace x with 0, it's 24 times 0. Figure it out? All right, so what did we get for when x is 0? What did we get? 0. 0. Okay. When x is 1, what did we get? 24. 2.
48.
3.
72.
Now, how is this table different than the last table? Other than the different numbers, what pattern do you notice in this table that was different than the pattern in the last table? Can we explain? Yes.
It goes up by
Okay. And in the last table, what happened?
It decreased by 3.
Decreased by 3. So I want you to pay attention. In the last table, gulps were going up, and the juice was going down. So they were working opposite directions. One was going up, the other was going down, right? In this one, cases go up, bottles go up. So they're actually both increasing. So they're not counteracting each other. Right? Okay, so our dependent, or our dependent is 0, 24, 48, 72. Okay, what pattern did you guys notice in the first table? Every time we take a gulp, what happens? Decreased by how much? 3. And in this one, every time we increase by 1 case, what happens? It increases by 24. These are the baby steps, the very first baby steps of the concept and study of slope. How many of you remember slope? These are called the rate of change, or slope. We use a letter M for the slope. And in this case, M is 24 over 1, or just 24. You don't need to know this yet. I'm just introducing it a little bit now. We'll get into slope. We'll spend a whole week on slope, like a month. Slope is a very important concept in Algebra 1, so we'll talk about that in detail later. But slope is just the pattern we see. It's important to identify it when we can. All right. Una más. Those of you who don't speak Spanish, una más means give me your money. What?
One more.
Oh, that's why that person wouldn't give me their money. El gato es no más horrible. Huh?
What's wrong with your cat?
I don't know. I just say things sometimes. Yeah, he called me stupid. Isn't that messed up? He didn't think I heard it. But see, I store that stuff in my memory bank. One day he's gonna be walking down the hall and accidentally fall into the lockers. Okay. All right, so this one is a little more complex. Let's walk through it together. The table here, it shows the percent lie of the moon that was visible at midnight, X days after May 19th, 2014. Our job is to interpret the domain and range. Notice how this terminology here changed a little bit. And then we are supposed to find the percent of the moon that's visible on May 21st, 2014. So, a couple things to notice here. First, do we see any equation here?
No.
No. Why didn't they provide us with an equation? Because we didn't need it, right? What did we use the equation for in the previous two problems? Find the range. And the range is already given. So we don't need to use the equation, plug it in to get the range. It's already given. Okay. The other thing is that this is worded a little strangely. Kind of hard to pick out the x and y, right? So let's talk about the x and y. And also it says here interpret, and before I think it said determine. So interpret's like If you were like working at a police station as like a detective, and I said, hey, go find me this person, you just go find them, right? If I said, hey, go interpret that person, you might put him in a room and cuff him to the table and slap him around a little bit, or ask him questions, or whatever police do. I don't know. What do I look like? A scientist? All right. So we're gonna dive a little deeper into the domain and range. We're not gonna stay on the surface. We're gonna get in there and wrestle with it. Okay. So what do we think the independent variable is here? Yes. What is your name? Favorite. Go ahead, Favorite. The days. Be more specific, because it is more specific. No.
The days after
Got it. Days after. $5.19. Okay. So what is our dependent variable? Yeah. Gabrielle. Okay. Ignore midnight. Yeah, it is at midnight now. Just percent of moon visible. Okay, this one is our X, and this one is our Y. You don't have to put X and Y necessarily, but I put them there just so we can see it. Okay. So this is not so straightforward as the last tables, right? So let's look at the domain. So if the domain is 0, what does that mean in the context of the problem?
Oh.
Your name?
0, Michael.
Michael, go ahead.
0 is May 19th.
Explain.
Because the days like 1 through 4 is the days after 19th. I mean May 19th. So 0 will be the amount that was amount of the moon that was visible on May.
Yes. So if we're 0 days after May 19th, what day is it? May 19th. So let's do this. Let's just next to your table, let's just put a little 519 there so we can remember that this is May 19th. Okay. So what is 1 day after May 19th?
May 20.
And then 21st, 22nd, and I didn't write the fourth one, which would be 23. Oh, this is not even the right table. That's why. Duh. All right. Okay, so now, also not completely obvious are the range. What is the range telling us? Yes.
It decreases
Speak loudly.
it decreases 0.11 every time. Like every single day.
Okay, it's decreasing by 0.11 each time. That's not what I'm asking. I'm asking, what does the range tell us? You're telling us the change in the range. We want to know what the range means. Yeah. Okay, the amount. So are we saying that there is 0.76 moon visible on May 19th? No. What does this say? What does this mean?
76% of the moon visible.
You got it. So they're in decimal form. We don't want to write 0.76%. We want to write 76%. And then, can you read me the other decimals? What was it?
65%. Then 54, 43, and 32.
Okay, and that's 50, 65, 54. All these are percents. Okay. So now we've dug deep into the domain and range. We understand what they mean. The table's not very clear about that. We talked about what each number represents. So now, what percent of the moon was visible on May 21st, 2014? Raise your hand. Let's get somebody new. What's your name? Tariq, go ahead. Good. All right. Now, whenever we have a word problem, generally we don't want to just write an answer like 54%. The end, right? So let's write this in a complete sentence. On May 19th, the moon was 54% visible.
May 23rd.
May 21st, thank you. Now let's go a little bit more. Why was it 54% visible? Because this was two days after May 19th. Hey, questions? Comments?
So after that, could you say, could you say that the rate of change that
Sure, you could. It's not asking us for that, but good. You're saying the rate of change is?
going down?
Okay, so the rate of change is actually negative 0.11. Whenever our rate of change is decreasing, our slope's actually negative. Again, don't worry about the slope. This is just, we're adding on to it. Okay. For those of you who have textbooks, you can find the practice problems we're about to do on page 299. Some of you don't, it's the orange one. Some of you don't have orange books under your desk. Hey, can you push stop on my phone?
Gotcha.